Hey everyone, and welcome. So today we're going to play detective. In our big case, it's a single drop of ink that might be hiding a secret. So let's grab our scientific magnifying glass and see what's really going on inside. Okay, so this is the central mystery. When you look at green ink from, say, a felt tip pen, it just looks green. But is that the whole story? I mean, could it be a clever disguise for something else? That is the exact question we're going to answer.
Now, you can't be a detective without the right tools, and ours is a pretty cool one. It's called chromatography, and trust me, it's a brilliant technique that lets us unmix colors to see what they're truly made of.
So what exactly is this thing? Well, chromatography is basically the science of taking a mixture of stuff that can dissolve in a liquid, like the different colored pigments that make up ink, and literally pulling them apart so we can see every single component. Now, the way this works is what makes it so cool. The absolute easiest way to think about chromatography is to imagine it's a race. A race for colors. We're going to line up all the pigments in our ink at a starting line and see which one is the fastest. The key to winning this race all comes down to one word: solubility. That's just a sciencey way of saying how well a color can dissolve in a liquid, like water. And in this race, the rule is super simple. The more soluble you are, the faster and farther you run. And of course, you can't have a race without a racetrack, right? Well, in chromatography, that's the solvent. It's the liquid. And for us, it's just going to be plain old water that dissolves the ink and carries those colors up the paper. The solvent moving up the paper is what makes the whole race happen. All right, so we've got our mystery, we've got our special tool. Now it's time to actually conduct the investigation. Let's walk through exactly how we can run this color race ourselves. It's actually a really simple 5-step process. First, we get our paper ready with a starting line. Then we put a little spot of our ink right on that line. We get our beaker ready with a bit of water, and then, this is the important part, we lower the paper in to start the race, making sure the ink spot itself stays above the water. Then we just get to sit back and watch the magic unfold. Now hang on. Here is a super important tip for all you science detectives out there. You have got to use a pencil for that starting line. Why? Well, pencil lead is graphite, and it's insoluble, meaning it won't dissolve and run up the paper. If you used a pen, that ink would start racing too, and it would just mess up our entire investigation. Okay, picture this. The paper is in the beaker, the water is just touching the bottom edge. This is it. This is the moment of truth. As that water, our solvent, starts to creep up the paper, what is going to happen when it hits our ink spot? As that line of water hits the starting line, it immediately starts to dissolve the ink. The pigments are suddenly freed from that single spot, and now they're ready to start their big journey up the paper. And they're off. The solvent carries the dissolved colors up the paper, and the great color race has officially begun. Now remember, each pigment has its own solubility, so they're going to start moving at different speeds, separating from each other as they go. All right, once the water can't climb any higher, the race is over. And what we're left with is this pattern of colors on our paper. This is our evidence. So now comes the fun part. Let's learn how to read these clues. You know, this finished piece of paper actually has a fancy name. It's called a chromatogram. You can think of it as the final police report from our investigation. This is our key piece of evidence, and it holds all the answers. So here's the most important part, and it's actually really straightforward. If your original ink was a pure substance, made of only one color, you're just going to see one single spot on the paper. But if it was a mixture, it's going to separate into 2, 3, or maybe even more spots. And we can learn even more from this. The number of spots tells us exactly how many different colors were in the mix. The height of each spot tells us how soluble that color is. The higher it traveled, the more soluble it is. And hey, what if a spot doesn't move at all? Well, that just means it's insoluble. It didn't even want to get in the race. So let's look at what could happen if our green ink separated into 2 spots, a blue one and a yellow one, and the blue spot traveled way higher up the paper. What does that tell us? It tells us that the blue pigment is the clear winner of the race. It's way more soluble in water than the yellow one. Okay, we've gathered the clues, we know how to read them. It's time to go back to our original suspect, that little drop of green ink, and deliver the final verdict. The investigation is complete. All the evidence is in. So after running our experiment, what did that final chromatogram actually show us? Was our green ink really just green after all? And the verdict is Case closed. The chromatogram shows not one, but two separate spots, one blue and one yellow. The conclusion is totally undeniable. The green ink was never a pure substance to begin with. It was a mixture of blue and yellow pigments this whole time.
And it all comes down to this one simple number, 2. There were two different colors hiding in plain sight, just pretending to be one. How cool is that?
Look, figuring out the secret of green ink is fun, right? But the real takeaway here is just how powerful this technique actually is. Chromatography gives us this amazing ability to look inside all sorts of mixtures around us, from food coloring to the pigments in leaves, and see what they're truly made of.
So we've cracked the case of the green ink, but this is just the beginning. This same technique can be used everywhere. So that gets you thinking, right? What's next? What mixtures do you have around you? Maybe the food coloring in your kitchen, the color from a flower petal? The investigation is now in your hands.